Hello everyone, it is the video which is continuation to applications of mesomeric effect. Previous video also applications of mesomeric effect. This is continuation to that. So mesomeric effect can explain sixth application. Mesomeric effect can explain basic strength of amines. Basic strength of amines. Basic strength of amines. Mesomeric effect can explain basic strength of amines. So what is basic strength? The tendency to donate lone pair of electrons by an atom or group is said to be basic strength. What is basic strength? The tendency to donate lone pair electron Lewis acid base concept. The tendency to donate lone pair electrons by an atom or molecule is said to be its basic strength. Okay. The organic molecule, in which lone pair electrons are delocalized or weak bases, while the molecules in which lone pair electrons are localized means fixed, not involved in delocalization, are strong bases. The effect of mesomeric effect is basic strength. How does mesomeric effect affect basic strength? Plus M effect. Positive mesomeric effect increases basic strength of organic bases, while minus I effect decreases basic strength. Okay, so this is the effect of mesomeric effect on basic strength. I will give some example. Take this one. See these 4 examples for those basic strength order, basicity order or basic strength order. For first example, here lone pair electron involved in delocalization like this. Whenever lone pair electrons involved in delocalization, that is weak base. Here lone pair electrons involved, but here some plus I effect. Plus I group increases basicity of amines. Here lone pair electrons not involved in delocalization, and this is what some plus I and this is what some minus I. So here lone pair electrons not involved in delocalization. So here delocalization, here lone pair electron delocalized, here lone pair electron not delocalized. That's why definitely which is strong base? C is strong base. Between these two lone pair involved in delocalization in both, but plus I group increases some basic strength. So B strong base than A. Next, see this second example. For second example, lone pair electron involved in delocalization. In this example, lone pair electron not involved in delocalization, because delocalization like this. There is no need of lone pair here. No need of lone pair here. So, if you see here, this is what some nitrogen, hydrogen, because nitrogen covalency 3. So here lone pair is free, completely free. That's why C is strong base when compared to here lone pair involved in delocalization, lone pair not involved in delocalization. Okay, so otherwise if you see this carbon is sp2 carbon and this carbon is sp3 carbon, sp2 carbon pull electron towards itself when compared to sp3. That's why this is very free. Here sp2 carbon pulling some electron towards itself. So this is the lone pair completely involved in delocalization. Therefore, B stronger base than A here. B stronger base than A. Here lone pair electrons completely involved in delocalization like this. So lone pair electrons are not free. Here lone pair electrons involved in delocalization, but more delocalization here. Lone pair involved in more delocalization. Here without lone pair also delocalization possible like this. So less delocalized. Lone pair involved in less delocalized. Less delocalization. Therefore, so if it is necessary, lone pair is necessary, that do not donate lone pair electron. A lone pair electron involved in delocalization but not necessary. So B stronger base than A. B stronger base than A. Next, see here, in all these 4 cases, lone pair electron involved in delocalization. All these 4 cases, lone pair electron involved in delocalization. Next factor, see, all are phenyl groups only, but here NO2 group is minus M group and methoxy group is plus M group. Here chloro group is minus I and plus M, but minus I is dominated for chloro group. Plus M effect is not dominated here. For this one, for methyl group, plus I group, plus I group and plus H effect. Plus I, H effect, hyperconjugation I will explain later. Okay, plus I, just remember plus I. So here which one is stronger base? Stronger plus M group increases basic strength. Plus M group on the oxygen atom of methoxy. Lone pair electrons are there that donate lone pair. Here it withdraw electrons. That's why lone pair electrons freely involved in this one. B stronger base. B stronger base. B is stronger base compared to next D. Compared to D, C, then A. This is basic strength order. Okay, the tendency to donate lone pair electrons by nitrogen atom is a basic strength of organic acid amine. Plus M groups push electron towards that nitrogen. That's why nitrogen easily donate electron pair. Tendency increases. Tendency to donate lone pair electron increases. Basic strength also increases. Plus M groups favor. Plus M group favor basic strength of amines. At the same time, minus M group decreases basic strength of amines. Mesomeric effect is always dominated over inductive effect. See this one. Next, I would like to continue this video with aromaticity. Aromaticity, one of the important topic in organic chemistry. Important topic which is somewhat related to resonance. So, I will explain here. What is aromaticity? Aromaticity is the character. Aromaticity is the character of. Aromaticity is the character of cyclic planar molecules, cyclic planar molecules with delocalized pi electrons, with delocalized pi electrons. The molecules which are cyclic planar and have delocalized pi electron. Such molecules character. Aromaticity is the character of cyclic molecule, that is planar also, that has delocalized pi electron. Aromaticity increases stability of organic molecule. Aromaticity increases stability of organic molecule. Aromaticity enhance stability of organic molecule. Stability of organic molecule. Stability of organic molecules. Based on aromaticity, organic molecules are three types. Based on aromaticity, organic molecules are three types. They are what? Aromatic, anti-aromatic and non-aromatic compound. They are aromatic compounds. Second one, anti-aromatic compounds. Anti-aromatic compounds. Third one, non-aromatic compounds. Non-aromatic compounds. Non-aromatic. Total 3. Okay. So what are aromatic compound? I will explain here. Aromatic compound, and I will categorize here anti-aromatic compound, anti-aromatic compound, and next third category, non-aromatic compound. Non-aromatic compound. What are aromatic compound? When will we consider that molecule is aromatic or anti-aromatic is non-aromatic? So if organic molecule satisfy Haeckel rule, that is said to be aromatic. So it follows Haeckel rule. Haeckel's rule. It do not follow compound. If you say compound, you can write it. It doesn't follow. It doesn't follows Haeckel rule. Haeckel's rule. It is also. It doesn't follow. It doesn't follows Haeckel rule. Follows Haeckel rule. Haeckel is the name of scientist. What is Haeckel rule? Satisfying Haeckel rule means molecule must be cyclic first of all, and planar mean sp2 carbon, sp carbons are planar, trigonal planar, sp linear. Linear is also in linear shape 2 atoms present in the same plane. In trigonal plane 3 atoms present in the same plane. But when you comes to sp3 carbon, that is tetrahedral, all atoms not present in the same plane. All atoms not present in same plane, that is not planar. Okay, right. See, next cyclic planar molecule, third one, that should be conjugated. Conjugated system in alternate single and double bonds, lone pair electron, conjugative system, already explained in last video, conjugative system. And fourth one, the molecule should have 4n plus 2 number of delocalized pi electrons. Delocalized pi electrons. 4n plus 2 number of delocalized pi electron. 4n plus 2 number means n is any integer number. If n is equal to 1, 4 into 1 plus 2, 6. If n is equal to 2, 4 into 2 plus 2, 10. Thus, how many electron? 6, 10, 14, 18, etc. Number of electron. Delocalized pi electron. That molecule is said to be aromatic. That molecule said to following Haeckel rule. Haeckel rule means molecule must be cyclic, molecule must be planar, that has conjugative system, and 4n plus 2 number of delocalized pi electron. N is any integer number. If you take integer numbers, that value, total value becomes 6, 10, 14, 18, 22, like that. That much number of delocalized pi electron. Those molecules are said to be aromatic compound. Next, here molecules must have cyclic structure. Molecules must have cyclic structure. Anti-aromatic compounds also cyclic. Cyclic structure. Second one, they are also planar. Planar in the sense sp or sp2 hybridization, not sp3. If sp3 carbon is present, that molecule is not planar. Third one, the molecule must be conjugated system. Then what is the difference between aromatic and anti-aromatic? This fourth one, that is 4n plus number of delocalized pi electron. 4n delocalized pi electrons. For aromatic compound 4n plus 2 number of delocalized pi electron. For anti-aromatic 4n number of delocalized pi electron. If n is equal to 1, that will become 4. If n is equal to 2, 8. N is equal to 3, 12, like that, 16, etc. That much number of delocalized pi electron. 4n plus 2 number of delocalized pi electron, aromatic. 4n plus 2 number of delocalized pi electron, that is aromatic compound. 4n number of delocalized pi electron, that is anti-aromatic. Except above two, these two, except aromatic and anti-aromatic. Except aromatic and anti-aromatic, remaining all compounds are non-aromatic. If molecule is not aromatic, if molecule is not anti-aromatic, that is non-aromatic. If molecule is not, if it is not aromatic, if it is not anti-aromatic, that must be what? Non-aromatic. So based on aromaticity, organic molecules are 3 types. Next, take this one. Aromaticity explains stability of organic molecule. Aromaticity enhances the stability of organic molecule. Aromatic compounds are more stable. So when you see stability order of different organic molecule, aromatic organic molecules are more stable than non-aromatic organic molecule, which are more stable than anti-aromatic. Anti-aromatic organic compounds are unstable. Anti-aromatic organic compounds are unstable. See some example. If you see this molecule, how many number of, is it first of all cyclic or not? Yes, cyclic. This carbon is sp2 carbon with positive charge. See, this is the carbon. If some atom, some group takes away this electron pair, and how many sigma? 1, 2, 3 sigma. Here some group eliminated with sigma electron. That means at this carbon no sigma electron. 3 sigma means which hybridization? sp2. So from this carbon, one of the group takes away sigma electron. That means this carbon has not sigma electron, only 3 sigma electron, positive. So this carbon is sp2. sp2 carbon means planar. All sp2 carbon means, all sp2 carbons means planar. Okay. Next, is it conjugative system? Double bond, single bond, positive, single bond, double bond. Yes, conjugative system. Yes, it is conjugated system. Next, how many number of pi electrons? 2 electron. 2 is Huckel number or not? Yes. If 4n plus 2 rule, in 4n plus 2, if n is equal to 0, 4 into 0 plus 2, that is equal to 2. 2 pi electrons in delocalization. Yes, Huckel number. That's why this molecule is aromatic. This molecule is what? Therefore, aromatic molecule. Yes, aromatic. Next, example 2. This is example 1. Example 2, if you take this one, cyclic or not? Yes, cyclic. Okay. Cyclic. All sp2 carbon. Yes, sp2. Double bond mean sp2 carbon. All sp2. That means planar. How I am verified? All sp2 carbon. sp2 carbon mean all sp2 carbon. That means planar. Next, conjugative system. Double bond, single bond, double bond, single bond. Conjugated system. Yes, conjugated system. Okay. Next, how many pi electron? 2 plus 2, 4. 4 pi electron. 4 pi electrons means this is anti-aromatic. Molecule. Anti-aromatic means unstable, highly unstable. Okay. Take this one. I will give some more example. Aromatic organic molecules are more stable compared to non-aromatic. Anti-aromatic organic molecules are unstable. Okay, next. Example number 3. Is it aromatic or not? This is which carbon? sp2 carbon, cyclic. All are sp2 carbon, cyclic and planar. Okay, cyclic and planar. Conjugative, single bond, double bond, single bond, double bond. Conjugative. How many electrons are involved in delocalization? How many electrons involved in delocalization? Take this molecule like this. These two electrons are not delocalized, they are at here only. So if this bond more electronegative atom always takes like this, oxygen minus, carbon is plus. Conjugative system or not? Yes, double bond, single bond, positive, single bond, conjugative system. How many electrons? 2 pi electrons. Cyclic or not? Only 2 pi electrons involved. These not delocalization. These pi electrons not involved in delocalization. These are involved in delocalization. So like this. Once comes charge to this delocalization involved here. So this is aromatic or not aromatic? Aromatic. Aromatic. So how this bond comes here, then double bond like this, and here positive charge. This carbon taking electron, this carbon losing electron, this carbon taking this pi electron and giving to this two. Then double bond formed here. This is positive. Next comes here. Then that leads to positive charge here, double bond here. Thus only this pi electron involved in delocalization, not this pi electron. Only this pi electron involved in delocalization mean only 2 pi electrons. 1 pi bond means 2 electron, 2 pi electron. Only 2 pi electrons involved in delocalization means aromatic compound. Taking fourth one. Is it aromatic or not aromatic? Cyclic or not? Yes, cyclic. Planar or not? Not planar. This is sp3 carbon. sp3 carbon means non-planar. Non-planar molecule means this is what? Non-aromatic. It is neither aromatic nor anti-aromatic. This is non-aromatic. It is not anti-aromatic, it is not aromatic. It is what? Non-aromatic. Next. If you take some positive charge here, cyclic or not, this is sp2 carbon, cyclic and planar, sp2 carbon, sp2 carbon, sp2 carbon, sp2 carbon. That means cyclic and planar. Conjugative system, double bond, single bond, positive, single bond, double bond, conjugative system. How many pi electrons involved in delocalization? 4 pi electrons. So this is what? Anti-aromatic. Anti-aromatic. Only 4 pi electrons involved in delocalization. Next example, if you take this molecule. Okay, this molecule, planar or not? Yes, planar. Cyclic, aromatic or not aromatic? This lone pair also 2 electrons, 2 plus 2 plus 2, total 6 electrons. 6 pi electrons involved in delocalization. Here only 4 pi electrons, 4 pi electrons, 4 pi electrons. But here 6 pi electrons involved in delocalization. This negative charge means 2 electron involved in delocalization like this. So delocalization like this. Total 6 electrons involved in delocalization. So this is what? Aromatic. This is what? Aromatic. Next, 7th one, if I take like this. Cyclic, all carbons are sp2 carbon, planar, that means planar, cyclic molecule and planar molecule, conjugative system, and 6 pi electrons involved in delocalization. That means aromatic. Benzene is aromatic compound. Benzene is aromatic. Delocalization like this. Next, if you see furan, this is important example. Molecule always try to become stable. So for that, it only involve it only involve one lone pair, not two lone pair. This lone pair not involved in delocalization. This lone pair not involved in delocalization. Only required number of pi electrons involved in delocalization. Like this. This pi bond comes here, this pi bond comes here. All are cyclic sp2 carbon, sp2 carbon, sp2 carbon, sp2 carbon. All sp2 carbon. Forget about oxygen. sp2 carbon, this is angular shape planar molecule only. So this is what? This is what? Cyclic planar conjugative system. Lone pair, single bond, double bond, single bond, double bond, single bond, lone pair, conjugative system. How many pi electrons? 6 pi electrons involved in delocalization. This is aromatic or not? Yes, aromatic. This molecule, its name is furan. Furan is aromatic compound. Remember this example. Next, example. Next example, pyrrole. Required number, only one lone pair involved in delocalization. This is aromatic. Why is it aromatic? 6 pi electrons involved in delocalization. Aromatic. Its name is what? Pyrrole. Pyrrole. Next example, this is similar to furan. Its name is thiophene. Thiophene. So only one lone pair involved in delocalization, this lone pair not. That's why this is also 6 pi electrons involved in delocalization, aromatic. Aromatic molecule, 6 pi electrons involved in delocalization. If you take pyridine, molecule pyridine, similar to benzene, but one of the atom is nitrogen. So here this lone pair is not required. Lone pair not involved in delocalization. That's why only 6 pi electron. 6 pi electrons involved in delocalization. Pyridine aromatic or not? Aromatic. Important example, aromatic. Its name is pyridine. Pyridine is aromatic organic molecule. Next example, if you take tropylium cation. Tropylium cation, all carbons sp2, this is double bond sp2, positive charge sp2, double bond sp2, double bond sp2, all are sp2, cyclic, planar, conjugative, double bond, single bond, positive, single bond, double bond, positive, conjugative system. Only 3 pi electrons involved in delocalization, 3 pi electron, like this. 3 pi bonds means 6 pi electron. 6 pi electrons involved in delocalization means, what is this? This is aromatic. This is what? Aromatic. Like this. Next, if you take naphthalene, this is benzene. Benzene or not? Yes, this is benzene. If you take naphthalene, how many pi electrons involved in delocalization? 1, 2, 3, 4, 5. 5 means 5 to the 10 electron. 10 electrons, 10 pi electrons involved in delocalization mean 6, 10, 2, 6, 10, 14, Huckel number, aromatic. This is what? Aromatic molecule. What is its name? Naphthalene. Naphthalene. Next, naphthalene. Next example, anthracene. Next example, anthracene. Three fused rings. Anthracene. Anthracene. How many pi electron? 1, 2, 3, 4, 5, 6, 7. 7 to the 14. 14 pi electrons. 14 pi electrons in conjugation mean 14 pi electron mean this is aromatic. Huckel number 14, 2, 6, 10, 14 are Huckel numbers, aromatic. Next very important example, that is biphenyl. Is biphenyl aromatic or not? Is biphenyl aromatic or not? 1 minute. Biphenyl aromatic or not? Okay. Total 6 electrons here, 6 electrons here. If you add them, it becomes 12. But that is not correct way. 12 is what? 12 is 4n number. Consider individually. This is aromatic, this is aromatic with 6 number. Aromatic. And this is also aromatic. Consider individually. Consider individually. Consider individually. That's why this is aromatic compound. Aromatic only. Okay. So thus we can explain aromatic and non-aromatic compound. We can understand this concept. Take this one. Anti-aromatic compounds are unstable. For example, cyclobute 1,3-diene. Anti-aromatic or not? Yes, this is anti-aromatic. Anti-aromatic means unstable. Since it is unstable, it can easily react with active metals. It react with active metals. So M is active metal. Active metal like sodium, potassium, iron. Active metal like sodium, potassium, aluminium, iron, etc. that react with such active metals, two active metals. Active metal lost 1 electron. First here homolytic bond fission takes place. Homolytic bond fission. 1 electron takes away by that carbon, 1 electron comes down. Okay. Next, that means here only 1 electron. 1 electron, metal give 1 more electron. Metal give 1 more electron means it become a lone pair. Lone pair, 2 electrons means this is negative charge. Here 1 electrons by homolytic bond fission, 1 electron given by metal. 2 metals give 2 electrons to 2 carbon atom. This is also negative charge. Okay. Thus 2 metals become positive. 2 metals become positive. So the type of reaction is possible here. If you see here bromine, or otherwise if I take which one is possible, which one is not possible. This is not possible. Here silver plus do not react with silver plus, talking about silver plus, do not react with this one, because If it lost electron, what happens? If it lost electron, it become positive. Anti-aromatic. If that lost electron, that become anti-aromatic. Anti-aromatic means unstable. This is non-aromatic. This is sp3 carbon, non-aromatic. Between non-aromatic and anti-aromatic, which is more stable? Non-aromatic is more stable. More stable. This is less stable. Less stable. That's why this reaction do not takes place. But below 1, that reaction easily takes place because this become positive and AgBr. This type of AgBr formation not possible here. Not possible. So this is what? Aromatic. Aromatic means more stable. Aromatic, this is what? Aromatic. Aromatic means more stable. Aromatic means more stable. This is what? Non-aromatic. Non-aromatic means less stable. Non-aromatic means compared to aromatic, non-aromatic is less stable. But compared to anti-aromatic, non-aromatic stable. That's why stable to more stable to less stable not possible, less stable to more stable possible. Okay, so this is application of one of the application of aromatic character. Take this one. See the next concept, that is ortho effect. Ortho effect is the chemical phenomena that occurs when two groups present at 1-2 relative positions of benzene means ortho group, ortho position. So this is the chemical phenomena that occurs only when two groups present at 1-2 relative positions on phenyl ring. So phenyl ring means benzene derivative is alkyl group of benzene is phenyl group. Ortho effect is caused by the combination of, what is ortho effect? It is the something effect that is caused by due to steric effect and bonding interaction and polar effects. Polar effects and bonding interactions and bulk group repulsions, all these results this ortho effect. Ortho effect results in different physical and chemical properties in disubstituted benzene compound. Ortho one of the example important, very important concept. Ortho substituted benzoic acid is more acidic. For only benzoic acid, aniline. Benzoic acid and aniline, consider for benzoic acid, ortho substituted benzene. Any group may be present at ortho position that is more acidic than other. Any group. In the similar way, ortho substituted aniline. Any group present at ortho position of aniline that is least basic, less basic compared to other aniline. Due to presence of some group at ortho position of benzoic acid, acidic strength of benzoic acid increases. Due to presence of some group at ortho position of aniline, basic strength of aniline decreases. Take these points. I will give some example for each benzoic acid and aniline. Right, acidic strength order of different benzoic acids. So acidic strength order. Acidic strength order. Acidic strength order. So here in first example, ortho effect. Any group present at ortho position of benzoic acid, strong acid. So definitely A is stronger acid among all. A. Next, between these three. So it is NO2 group is minus M group. Minus M group decreases acidic strength. Here minus M group and here neutral. Neutral is somewhat better than minus M effect. Neutral benzoic acid stronger than minus M effect. Minus M effect at meta position is weak. Mesomeric effect at meta position is weak and at para position is strong. So minus M effect is unfavorable, weak. Unfavorable effect at weak position is better compared to unfavorable effect at strong position, that is C. Okay, minus M effect is unfavorable effect. Unfavorable effect at weak position is better than unfavorable effect at strong position. Okay, next between these four. So definitely this is what more acidic, because any group present at ortho position, that is stronger acid. Definitely A is stronger acid among these four. Next between these four. So this is what methyl group is plus I group, and also this is double bond and alpha hydrogen. Double bond and alpha hydrogen means H plus H effect. Hyperconjugation next class, our next class hyperconjugation. Here also what plus I group and plus H effect, hyperconjugation effect is there. This is neutral. This is what neutral. Now my question, which is strong acid between BCD? You know, plus I group decreases unfavorable group. Unfavorable group at meta position is weak. Unfavorable group. Plus I at meta position is weak, minus I at meta position is strong. I will write that point, important point. Minus I effect at meta position is strong. Meta position is strong. Note, remember these points, important. Next, plus I effect at meta position is weak, minus I effect is strong at meta position, plus I effect is weak at meta position. Okay, just remember this point. No reason is not required here, just remember. So mesomeric effect at meta position is weak, minus I effect at meta position is weak, plus I effect at meta position is weak, minus I effect at meta position is strong, plus I effect at meta position is weak. So here unfavorable, plus I effect at meta position weak, plus I effect to para position is strong. Okay, so this plus I effect benzoic acid, plus I group unfavorable, plus I effect unfavorable for acidic strength of benzoic acid, because conjugate base is benzoate anion. Anions destabilized by plus I group, anions stabilized by minus I groups. So this is plus I group. So benzoic acid acidic strength explained by benzoate anion stability. That anion is destabilized by plus I group. So unfavorable group at weak position, unfavorable group at strong position. This is better. So B is strong acid. There is no unfavorable group. This is better. Unfavorable group is not present. So D is stronger acid. Unfavorable group at weak position. So B is stronger acid. Unfavorable group at strong position. So C is definitely weak acid. So next here, any group at present at ortho position, that may be any group ortho position, ortho effect stronger acid. Blindly say A is stronger acid among these four. A. Next between BCD. So here what about X? X is what? Minus I group. X is minus I group. Minus I group at meta position is strong. Minus I group at para position is weaker. Here no group. So minus I group favorable for acidic strength. Minus I group increases stability of conjugate base benzoate ion. After donation of H plus ion, conjugate base is benzoate ion. Benzoate ion is anion stabilized by minus I group. That is why, which is stronger acid between these two? Minus I effect is favorable effect at a stronger position. Next, favorable effect at weaker position is next. There is no favorable effect, so D. So in this way we do. So mesomeric effect at meta position is weak. Plus I effect at meta position is weak. Minus I effect at meta position is strong. Remember this point. So take this one. I will explain for basicity of aniline. So any group present at ortho position of benzoic acid, more acidic. Any group present at ortho position of aniline, weak base. Benzoic acid becomes strong acid. Any group present at ortho position of benzoic acid is stronger acid. Any group present at ortho position of aniline is weaker base. Take this one. Next, take this one, basicity of aniline, basic strength order. So you know any group present at meta position of aniline is weaker base. So definitely here NO2 group is what? NO2 group is minus M group. Chlorine is, it has plus M effect and minus I effect, but for halogen minus I effect is dominated. This is minus I and minus M dominated. For only halogen, inductive effect dominated over mesomeric effect. So for this one, for methyl group, plus I group and plus H effect also, hyperconjugation also stabilizes here. Here methoxy group, that is definitely plus M group. Plus M is dominated over minus I group here. So minus I group plus M group, but plus M effect is dominated here. So basicity is the ability to donate lone pair electron. To donate lone pair electron, electron releasing groups are favorable. Plus M groups are favorable. So definitely which is stronger base among these four? D is stronger base. After D. So minus M unfavorable effect, minus I unfavorable effect, strong unfavorable, weak unfavorable effect, strong favorable effect. So C is stronger than weak unfavorable effect B, and last strong unfavorable effect A is basicity order. Okay. Next, consider second example. Any group, that may be any group at present at ortho position, ortho effect weaker base, ortho effect. This is what? Minus M group. At which position? Meta position, weak. And here minus M group at para position, strong. Here no, neutral. No effect, neutral. So which is weaker base among those four? Definitely A is very weak base. Any group present at ortho position of aniline, weak base. Next, here all these unfavorable, and all are unfavorable. This is neutral. So D is stronger base. Unfavorable group at meta position is better. So B. Unfavorable effect at strong position. Always ortho substituted aniline is very weaker base among all those, anything. Okay. Next, this is ortho effect. Here ortho effect, that's why this is weaker base. Next here plus I group and plus H group. But plus I group at meta position weak, and plus I group at para position, plus H effect also. Plus I at meta position weak and para position strong. This is neutral. Plus I group increases basic strength of amines. Plus I group increases basic strength of amines. Plus I group mean electron releasing group. They increase the tendency of nitrogen to donate lone pair. Some electron releasing group push towards electron towards nitrogen, then nitrogen freely donate electron pair. Definitely which is strong? Plus I group weak position, plus I group at strong position, stronger effect. So plus I is favorable effect at strong position, definitely stronger. Plus I effect, favorable effect at weak position, somewhat better. B. There is no favorable effect. D. Ortho substitute aniline is always weaker base. So this is about ortho effect. Hope you understood well. Okay. Please like, share this video. Thank you.